addition and multiplication rules. We finished the addition rule. Now we're getting ready to start the multiplication rule. And this is only part of the multiplication rule. It also has a more complicated piece to it. But for the basic premise, and we've already used this Venn diagram to show compound events and an intersection, an overlap, to where event A shares events with event B. And the key word in there is and that is the word for the multiplication rule, and. Remember that or means to add. So here's our formula. The probability of A and B equals the probability of A times probability of B. This is an intersection of events. Intersection. They're merging, they're hitting. That upside down U is the symbol for intersection. With the multiplication rule, you're dealing with separate trials or events that are going on. They can affect each other also. This is an effect, that intersection. But what we're going to talk about is looking at where they're separate. For instance, if I was looking at flipping a coin and rolling a die. So I flip a coin, I want to get tails, and I am rolling a die and I want a 6. These are two separate trials or events that are occurring. The probability of tails is simply 1/2. There's two sides to the coin, so 1 over 2. The probability of rolling a 6 is 1 out of 6. There's 6 sides to the die, and only one of them has the number 6 on it, so 1 out of 6. The other 5, 1, 2, 3, 4, and 5 are on those faces. Then all I do is multiply them together. 1/12 chance. This is how casinos make their money. Those odds, that's around 8% chance that you could just do something as simple as flip a coin, get a tail, and roll a die and get a 6. 8% chance of that occurring in that event. So this can be more complicated. What I want to do is the bulk of this video, we're going to work a problem using the rules we've already learned and reasoning through why we did what we did. So here's our problem. New cell phone is under development, and a batch of these phones were examined for operating malfunctions. 6,813 of them, to be precise. And it was found that 521 of them failed the test. So if the operating system is checked in, let's say, 4 different phones, and the entire batch is accepted if no malfunctions are found, what is the probability that the operating system is operating correctly? So the first thing that we do with these problems, or at least I do, is I start with writing down the important things that I need from the problem. So one of the main things is I identify the sample space. Sample space is n, right? Our total number of possibilities, total number of possible outcomes. 521, that's how many failed. So they did a test, and out of those 6,813, 521 failed. That's my x. That's the favorable outcomes. But I want you to notice in the question, they're not asking about failures. The final part, what is the probability that the operating system is operating correctly? They want to know about the number that do not fail. Complements. So we're going to pull in our complements here in working this problem. And the easiest way to do it is, instead of saying, okay, these failed and these worked correctly, is say fail, not fail. Probability of A is fail, probability of not A is not fail. And then the probability of A is 521 over 6,813. Again, what we were given, the number we were given were those that failed. That's the total number. So favorable outcomes, total possible outcomes. Get out the calculator. So around 7% of them failed. 0.07647. That's what we'll write down. But I do not want to know the number that failed, right? I'm looking at not failed. That's what I want to do. So therefore, I'm going to say 1 minus the probability of A is equal to the probability of not A. All I did was rearrange the equation that we had worked on with complements, right? I add both of those together, they equal 1. I just rearranged it. So what I'm looking at here is simply 1 minus 0.07647. And that is going to give me my value of not failed or working correctly. So I will take this and I will say 1 minus 0.92353 is what I write down. This right here, even though we're calling it not failed, this is the ones that are working correctly. How we have it labeled, not failed. Okay, so I have found my probability. The successful numbers of those that are good and they're going to be shipped out. So what the question says is that there were how many different tests? 4 different tests. So what I know that I have, slide this up, is something like this. The probability of not A and not A and not A and not A. Okay, so the way to conceptualize this is that the initial data that they gave, this is the batch that they looked at. We found the percent or the decimal for those that failed. We did the complement so that we could find those that worked correctly. And what the question is asking me, again, is what's the probability that the operating system is operating correctly? They tested it 4 times on 4 individual phones. Okay, they pull it out and they test it. So that's why I have this written out. And I'm going to use the multiplication rule, because what this actually means is the probability of not A, or working correctly, times the probability of not A again, and I will do it 4 times. Which I can also just simply write as this: the probability of not A to the 4th power. So all that means is that I can say 0.92353 to the 4th power. I am dealing with a number less than 1, and I am taking it to a non-negative integer. I'm going to end up with a number smaller. And it's important to be able to critically think about what you're doing. Over here to the side, any of your fractions, remember, you're just multiplying across. Your denominator is always going to get bigger. So I multiply 1/2 times 1/2. That's just 0.5 times 0.5. I end up with 0.25. I end up with a smaller number. I know that I'm going to have a smaller number than what I started with. The closer I get to 1, the closer my answer, or it's not going to become as small. So let's just see what we get. So I have 0.92353 to the fourth power. And y'all can't see it on there. I'm finding the balance of my lighting. So here is the answer. 0.727. 72% of them will be good and will be operating. And this is the basic premise. So what they've done is they've put in the rule for complements in there along with the multiplication rule for you to be able to work your problem. Okay guys, continue to watch the publisher's videos, read your text, structure, critically think about your homework, analyze what you're doing, and good luck on the rest of your homework.